Dr. Gade sir.
Yes, sir.
Okay. Shall we start now?
Okay, sir. Okay.
There are 30 participants joined, and we can start our workshop.
Am I audible, sir? Good afternoon.
Let me try something. Right now, diagram.
Am I audible?
Yes.
Namaste and good afternoon, ladies and gentlemen. I, Dr. Gade here, extend a warm welcome to each one of you in the online one-day state-level workshop on a differential equation and its application, organized by Department of Mathematics, Arts, Commerce and Science College, Kille Dharur, District Bid. We are privileged to have with us renowned guests, reverted educators, and esteemed participants who have gathered here virtually for various concerns of the state to explore the world of mathematics. Mathematics, as we all know, is the language of universe, and today we will decode one of its essential chapter, differential equation and its application. I am pleased to introduce our esteemed dignitaries.
Participants are requested to unmute their mic.
I request all the participants please mute their mic throughout the event. If anyone has any doubt at that time, just unmute yourself and ask your query. Otherwise, you can ask your question in the chat box also. So it's kind request to all the participants. I am pleased to introduce our esteemed dignitaries who grace this occasion with their presence. Our Honorable President, Dr. Gopal Kakade, the respected principal of our college, a guiding force behind our academic excellence. Our chief guest, Dr. Shankar Raut from KSK College, Bede, an eminent scholar whose knowledge illuminates the world of mathematics. The diligent convener, Mr. Mahadev Zogde, Head Department of Mathematics, whose efforts have shaped this event. Dr. Milind Gaikwad, sir, Vice Principal of our college. Ladies and gentlemen, we are intellectually stimulating our experience today. Our program explore diverse application of differential equation in the real world. Let's start the workshop with enthusiasm. I encourage each one of you to actively participate, engage throughout the sessions. Now, I invite our Honorable President, Dr. Gopal Kakade sir, to inaugurate this workshop officially and bless us with his word of wisdom. Thank you. Over to you, sir.
Thank you, Dr. Anand Rao. Good afternoon to all. At the very outset, I welcome all the dignitaries, faculty, participants, and all students in this state level workshop organized by Department of Mathematics, MSP Mandal's Arts, Commerce and Science College, Killi Dharur. So it's an honor to inaugurate this workshop on differential equation and applications. I greet all virtues attendees warmly, echoing the words of Carl Friedrich Gauss: mathematics is the queen of the science and number theory is the queen of mathematics. Actually, to be frank, I am from other discipline. That my subject is chemistry, and I in my school days uh, have problems with mathematics because I was not getting the easy concepts of this mathematics. And but as soon as these disciplines were in contact with me and the persons of mathematicians were in contact with me, I was interested in this mathematics. And today's differential equation and its applications. I greet all virtual attendees. Also, differential equations are crucially in understanding complex systems with applications spanning various disciplines. This will provide a platform for collaborative learning beyond mere education, engaging actively asking questions and embracing this chance for deep understanding. This workshop will prove a benchmark. This workshop also will serve as an unique platform for all of us to unravel the versatility of differential equation, comprehend their significance in various fields, and witnesses how they can be wielded to address real world challenges. It is more than just an education event. It is a space for intellectual exchange and collaborations. My gratitude to the organizing team and our esteemed chief guest, Dr. Shankar Raut from KSK College, Bid, for their contribution. Remember, knowledge is a journey that empowers us to contribute meaningfully. I declare this workshop open, hoping it inspires and enlightens all the participants, budding researchers, students, and I wish you all the best for this workshop, and be connected online till the end of this workshop, and hope this workshop will bring some new productivity. Thank you.
Thank you, sir,
Thank
for
you.
your encouraging words. Now, I will call on the screen convener of this event, head of the Department of Mathematics, Mr. Mahadev Zogde sir, to gather. Hello.
Hello.
To express his view on this event. Over to Zogde sir.
Good afternoon. A warm welcome to our esteemed dignitaries, faculty, participants, and students in this workshop on differential equations and its applications. Today, we explore their real-world applications and collaborative potentials. I am grateful to our President, Principal Dr. Gopal Kakade sir, and Chief Guest Dr. Shankar Raut for their support To all participants, engage actively, ask questions, and collaborate. Let us make this workshop a platform for profound learning and fruitful exchanges. I officially declare this workshop open. May it inspire and enlighten us. Thank you. And here is to a day of insightful discoveries and shared knowledge. Thank you.
Thank you, sir. Ladies and gentlemen, our chief guest, Dr. Shankar Raut, sir, is a luminary in the field of mathematics. I will introduce our guest. Dr. Shankar Raut, sir, is currently working as an associate professor and head in the Department of Mathematics at KSK Arts, Science and Commerce College, Bede.
Okay.
He is expert in differential equation analysis and number theory. He holds a PhD degree from Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, with a focus on advances in a fractional differential equation and its application. With profound passion for mathematics, he has participated in 33 national and international conferences and has organized 5 conference and workshop. Dr. Raut sir has participated in 21 national and international conference by presenting her research paper there. Sir has published 9 research papers. Additionally, he has authored a book on group theory. His contribution have been recognized through prestigious awards. He was honored with National Best Teacher Award in 2020 and Young Research Award in 2022. Apart from his academic achievement, he is actively engaging in various committees at college and university level. We are truly honored to have him with us today. Now I invite our chief guest, Dr. Shankar Raut sir, to enlighten us with his insightful discussion on a differential equation and its application. Over to Dr. Raut sir.
Thank you, sir. Am I audible, sir?
Yes, sir. Yes.
Can I share my screen, sir?
Yes, sir. You are co-host. You can share your screen by screen sharing option.
Thank you for the brief introduction. Is my screen visible, sir?
Yes, sir. It is visible now.
Okay. Thank you. Good afternoon to all. Myself, Dr. Shankar Raut from KSK College, Bede. I am working as associate professor and head Department of Mathematics from 2003. First of all, I very much thankful to the management and the principal, Marathwada Shikshan Prasarak Mandal College, Arts, Commerce and Science College, Kile Dharur, and convener and head Department of Mathematics, Dr. Jogde sir, and also co-convener Dr. Gade sir, for inviting me as a resource person for this one-day state level workshop on differential equation and applications. Also, I thanks to Vice Principal Dr. M.N. Gaikwad sir and all the management of Arts, Commerce and Science College, Kile Dharur. So friends, this workshop is very helpful because you know that we all know that the government of India implement the national education policy from 2020 from this year at PG level, and from next level we are ready for the national education policy at degree level also. So in this national education policy, it is focused on the skill based education and field project and practical education. Friends, in mathematics, different skills are needed today for solving different equations, differential equations, and also it is important to apply the mathematical concepts in today's information technology and life also. In this NEP system, skill-based workforce is very important because unskilled work is done by machine, but we need a skill force power. You know that in India, 60% of the population is young, and so that old policy is replaced by National Education Policy 2020 to give the work for this young people, and so we need the skill-based education in this new education policy. In mathematics, there are different skills, different softwares are developed to do the modeling of differential equations. ICT skills are also in mathematics. This workshop is important to know about the different applications of differential equations and different applications of mathematics. So my topic of, again, I thankful, first of all, I thankful to the management for inviting me to express my views in this state level workshop on differential equation and applications. My topic of presentation is differential equation and applications. We know that the nature is variable and whole universe is variable. Nothing is fixed and constant. So nature is also variable because whole universe moves. Also, Earth moves around the sun. Also, sun moves with solar system in the universe. To study the change in nature, we need to study the different physical quantities and the interrelation among them. And to do that, we know about the mathematical concept, calculus, and mainly the differential equations, because it helps to study the rate of change of one quantity with respect to another quantity. So I choose here the topic differential equation and its application. Outline of my presentation are introduction, definitions regarding some basic definitions, then classification of differential equation, linearity of differential equation, solution and origin of differential equation, initial value problem, boundary value problem, existence uniqueness, methods of solution, application in various fields in day-to-day life of differential equations and references. So friends, the theory of differential equation is an important branch of science and engineering. In the last 3 decades, most captivating branch in the field of mathematics is the calculus, and mainly the fractional calculus, fractional differential equations also. It is a recent branch of differential equation and calculus. Differentially, hello? Am I audible?
Yes, sir, you are audible.
Okay. The differential equation is an essential tool to
So please unmute yourself.
Okay. Am I audible?
Yes, yes.
Naturally, here, essential part of modeling for computer graphics and visions, and also in games. Most dynamical systems of physics, social science, biological, chemical, engineering, etc. are often modeling. So to understand the natural change and investigate the problems involving the motion of fluids, flow of current in electric circuits, waves, conduction, heat, also elasticity, viscoelasticity, population growth, and many other modeling. The study of differential equation is very essential here in day-to-day life. Mathematics, you know that mathematics is a alphabet, and in which God has written universe. By using mathematical modeling, I mean, God is a great mathematician and he wrote whole universe in the language of mathematician. And we only know 2 or 3% of mathematics, of the total mathematics. Everything in the nature is at correct place, and God put everything, every object in the universe at the correct place by using mathematics. So God is the great mathematician. So here, I focus on the classical calculus, and in that mainly the ordinary differential equation and partial differential equations. Here we know that in mathematics very basic concepts are set and functions. Functions are used to interrelate physical quantities, 2 or more physical quantities, and to find the interrelation and between the quantities, different quantities, physical quantities, we need derivatives. Means derivative of one quantity with respect to another quantity. Means there are variables, dependent and independent variables, and we take rate of change of dependent variable with respect to independent variable. We mean independent quantity. So some quantity, for example, velocity is depend on time, and rate of change of velocity is an acceleration. So acceleration is equal to dv by dt. And so here, like this, different physical quantities are interrelated by using rate of change. That means by using derivative. The differential equation means an equation involving the derivatives of dependent variable with respect to independent variable. And that is very important to study the nature, because In nature, nothing is fixed. Everything is movable. And to study the moving things, it is need to study the rate of change of that quantity. So here, the differential equation, you know that it is a very important branch of mathematics, main branch of mathematics, because in day-to-day life, this is a time of information technology. And in this information technology time, we need a modeling, mathematical modeling of everything. So differential equations are very important in that case. So here are the examples of some basic differential equations. dy by dx equal to 2x plus 3. This is one of the differential equation. dy by dx is derivative of y with respect to x. Y is here function of x, and we take derivative of y with respect to x. That is the rate of change of y with respect to x. So these are the some examples also. Here in second example, derivative of y with respect to x is taken, and there are two terms having derivatives, dependent variable and its derivatives. So such equations are known as the differential equations. Y is dependent variable and x is independent variable. And here these examples are the examples of ordinary differential equations. We mean, you know that in very basic point, it is ordinary differential equation contains only single independent variable, and the derivatives of functions with respect to single independents are taken. So this is these are the examples of ordinary differential equations. So there are the another type of, this is another type of differential equation known as a partial differential equation. In this type, there are two or more independent variables, and derivatives of different functions depend on that two or more independent variables are taken, and the equation containing these partial derivatives. Partial derivatives are denoted by dou u by dou x, partial derivative of u with respect to x, and dou u by dou y is partial derivative of u with respect to y. So this is second order equation. You know that very well. This is known as Euler equation also in partial differential equation. Here u is dependent, x and y are independent. U is dependent on x and y, and derivatives of u with respect to x and y is taken in this first example. And also there are two more examples I stated here. The derivative of u with respect to x and t. U is dependent on here x and t. And in last equation, u is dependent on also x and t. So these are the examples. And now here we classify the differential equation in two parts, depend on the number of independent variables. In ordinary, one independent variable, and in partial, more than one independent variables. Also, to classify the differential equation, we need order and degree. Classification of differential equation is also depend on the order and degree of differential equation. So what is mean by order? Order of differential equation is the order of highest order derivative in the differential equation. These are the some basic concepts I only state here and recall that. So here in first example, order is 1 because highest order derivative in this equation is 1. Only one derivative is there. Highest order derivative is also that 1. Therefore, order of the differential first differential equation is 1. Also, in second equation order is 2. In third equation order is 3. Because highest order derivative is third order d3y by dx cube. But here order is not 4 because here 4 is not a order. It is actually the degree. So what is meant by degree? We define that also here. So 4 is power, not a order. Therefore, it is third order equation. Now again here define the concept of degree. The degree of the differential equation is the power of highest order derivative. appearing in the differential equation, given differential equation. So here in these are the some examples. In first example, order is 2 and degree is 1. In the second example, degree is not 4, it is 1, because highest order derivative is third order and its power is known as the degree. So in last equation, last example, degree is 3, not 5, because highest order derivative is second order. So classification of differential equation is depend on the number. So mainly, this is one of the important type of differential equation, linear differential equation. So what is meant by the linearity concept is related to the degree 1. Actually, the differential equation is linear if dependent variable and its derivative are of degree 1. It is not depend on the independent variable. So linearity concept is depend on the dependent variable. So coefficient of a term does not depend upon dependent variable. So only see example here, some examples. So this first example is in which y and its derivatives are given, and in first term degree is 1, second term degree is 1, and third term y with power 1. So it is linear equation. But in second example, here the second term is not a linear, it is non-linear, and so it is non-linear differential equation, because power of dy by dx is 4 here. Here the degree and order of differential equation is important to classify. You know that at degree level, at BSc level, so there are 2-3 papers of differential equations. In first year, there is in one paper differential equation. Now it is in new syllabus, it is in second year. Also in second year, partial differential equation is there, and ordinary differential equation is in syllabus of third year. So there are 3 papers of differential equation at degree level, because to study the differential equation is important in mathematical modeling and also in application point of view. So today here we study about the different concept of differential equation. Here linear differential equation, there are different methods, and linear differential equations are important and their solutions also important. So here are the some examples of to define linearity and non-linearity concept. In this example third, so here the second term is y into dy by dx, non-linear, and also in fourth example, the sin y, you know that sin y can be expressed in series form as y minus y cube upon 3 factorial plus y raised to 5 upon 5 factorial dash dash dash. This is non-linear because degree of y is not 1 here in every term, so it is non-linear. So here are some examples, and we classify these examples in different types, depend on the number of independent variables and degree and order. So you do yourself this thing. So first example is first order and first degree, and it is ordinary differential equation and linear also. Similarly, for second equation, it is non-linear. Y cube is non-linear term, and it is ordinary because independent variable is x only here. And here last 2 examples are examples of partial differential equations. Seventh example is you know that very well, it is a wave equation. U is depend on x and t. T is time here, and it is of second order and degree 1, and it is partial. So here the order of differential equation in recent study, in recent research of mathematics, the order of differential equation is fractional also. Fractional means order is not only the integer order. In classical calculus, it is order of differential equation is integer. Order of derivative is integer. But now the recent branch of calculus is the fractional calculus. And in this calculus, the degree, it is possible that degree of, not degree, order of differential equation is fractional, fraction. From this last third decade, 3 decade, this fractional calculus is the branch of mathematics and a recent branch of mathematics. Very applicable in different types of modeling, mathematical modelings. Modeling of diseases, suddenly changes, then modeling of diffusion models, wave models, fractional models of wave fractional models. My research topic is also on the fractional calculus, advances and applications in fractional calculus. I am doing my research. I have completed my research under the guidance of ex-BOS chairman, Dr. Bhausaheb Sontakke. I am taking there the different fractional models like Kawara equation, also Hirota Satsuma KDV, coupled KDV systems, and also gas dynamic equations for my research. So that is the recent branch, but I am not focusing on that point. I am focused. I here focus on only the classical calculus. So here we consider first order differential equation. General form or derivative form is this: a1 of x dy by dx plus a0 of x y equal to g of x. Differential form, this is differential form, and general form is dy by dx equal to f of x comma y, or f of x comma y into comma dy by dx equal to 0. So there is a difference between these two writing here. In first form, dy by dx equal to f of x comma y, it is linear in dy by dx, but it is not guaranteed that it is linear in y or x, but it is linear in dy by dx. But in second form, it may or may not be linear in dy by dx and y also. So this is the difference here. So first order equation also can be written in different forms. This second is the derivative form. Also, in you know that in first year syllabus, so differential equation of this form mdx plus ndy equal to 0, and also the methods of solving also these differential equations. So here are the different forms. The last form is also linear form, first order linear differential equation, dy by dx plus p of x in y equal to q of x here. So these are only the different writings of first order differential equations in different forms. So here the second order, some examples of second order differential equation, and we write second order differential equation general form f of x comma y in dy by dx comma d2y by dx square, because in second order equation there is a highest order derivative is d2y by dx square, and first order is also that is also included in that second order equation. So these are the different forms of second order equation, and also equations are of third order up to nth order. General form of nth order differential equation is this. Actually this is a linear nth order differential equation with constant coefficient and also with variable coefficient is this here. This can be written in short by using the operator L. So we write left hand side by L of y, and we write it as L of y equal to g of x. And also There are different methods of solving such type of equations. Here also there are two types of linear equations which are homogeneous. Means if right side is 0, g of x is 0, then L of y equal to 0, which is homogeneous. And if g of x is not equal to 0 for some x belongs to interval I, then it is non-homogeneous. And here the solution of such type of equation is important. There are different methods of solving such equations. Now, what is meant by solution of differential equation? Because if there is an equation, then we try to find the solution. The solution is the relation between dependent and independent variables. That is function of dependent and independent variable by means of that relation and its derivatives obtained from that relation. The given differential equation is satisfied. You know that very well, this definition. And if we put that values in the differential equation, we get LHS equal to RHS. So that is meant by solution. So solution is so very important because there are different types of differential equations. And if we not know the solution, then it is not important that the differential equation, we cannot study that differential equation. So the solution is important for differential equation. There are different types of solutions: general solution, singular, particular solution, singular solutions. So what is meant by for homogeneous equations, there are actually only one part of solution. You know that is a complementary function is same as the general solution. And also you know that in general solution, the number of arbitrary constant equal to the order of differential equation. That constants are the parameters of solution. Here are the some examples of solution. Here y equal to 3x plus c1 is the solution of first order differential equation. Dy by dx equal to 3 c1. c1 is arbitrary here. So here dy by dx is first order and the solution contains only one constant c1, and so it is general solution. The solution contains number of arbitrary constant equal to order of differential equation, then the solution is general solution. Also there is another example. Here y dash equal to sine of x, that is y equal to minus cos of x plus c. Both are the solutions of y double dash. So here y dash is first order derivative and y equal to minus cos x plus c is the solution of that equation. Y double dash equal to 6x plus e raised to x. And solution of this equation is y equal to, by taking 2-time integration, we get solution y equal to x cube plus e raised to x plus c1 x plus c2. So there are two arbitrary constants and order is 2, so it is general solution. And solution obtained from general solution by giving particular values for the constants c1 and c2, or the arbitrary constants, we get the particular solution. And singular solution is obtained by eliminating that constants, arbitrary constants, from general solution. So here is the some families of solution. So consider this differential equation 9y into y dash plus 4x equal to 0. We integrate this, we get the solution here. So 9y square plus 4x square equal to 2c1 is the solution by integrating. And that can be written also like this: y square upon 4 plus x square upon 9 equal to c. Here c is arbitrary constant. C, we write c for c1 upon 18. Okay. And so geometrically, what this indicate? This equation, that solution containing one constant, that is we consider that is parameter, then this is a family of ellipses. You know that standard equation of ellipse, x square upon a square plus y square upon b square equal to 1 here. But here, this also indicate the family of ellipses center at here around in x-y axis system. So here, observe that given any point x0, y0, there is a unique solution of the curve, and for different values of c, we get different curves. Okay, are you understand? So another family here, the geometric origin of differential equation is actually derivative is the rate of change of quantities with another quantity. So here, one of the example, family of straight lines. You know that straight line equation of straight line is y equal to mx plus c. So here we consider two parameters c1 and c2, and if we find the corresponding differential equation, then corresponding is differential equation is second order, d2y by dx square equal to 0, okay, by eliminating these constants c1 and c2. So also the family of curves y equal to c into e raised to x square by 2, the corresponding differential equation is dy by dx equal to xy. And in last B, example B, y equal to c1 e raised to 2x plus c2 e raised to minus 3x. The corresponding differential equation is second order by eliminating c1 and c2 here. So you know that applications of differential equations in different fields, you know that in physics, chemistry, also in biology, in bioscience, different modeling is done by using differential equations. So in physics, you know that free falling stone, one of the example here, equation of free falling stone is d2s upon dt square equal to minus g. Minus g is because it is towards the earth. G is the acceleration due to gravity, and s is the distance or height of free falling stone. Also another example is here, spring vertical displacement. Differential equation is, you know that m into d2y by dt square equal to minus ky. Y is the displacement, m is mass, and k is spring constant. Also, you know that in electrophysics, RLC circuit, Kirchhoff's first law and second law, you know that in physics, there is a differential model of RLC circuit. If Q is the charge on capacitor, L is inductance, C is capacitance, R is resistance, and E is voltage across the wire, then the differential equation formed by using Kirchhoff's second law is this: L into d2q upon dt square plus R dq upon dt plus 1 upon cq equal to E. These are the differential equations occurs in physics, physical sciences, but it is important to find the solution of such type of equations: first order, second order, homogeneous, non-homogeneous, linear, non-linear. So we need to know the methods of solving different types of differential equations, because in the mathematical models, different types of differential equations occurs, and mathematics gives the methods of solving such models. You know that also Newton's law of cooling is given by corresponding differential equation is dt upon d capital T upon dt equal to k into dt minus ts. Rate of cooling is with respect to time. So dt upon dt is the rate of cooling, and T minus Ts is the temperature difference between the liquid T and its surrounding. Ts is the temperature of surrounding, and T is the temperature of liquid at time T. So T minus Ts is the difference. So mathematical model for that Newton's law of cooling is this: dt upon dt equal to k into T minus Ts. So also you know that growth and decay of different elements, also in biology, population growth is there. So here is the model of growth and decay is dy by dt equal to ky. Y is the quantity at present, k is the constant depend on that substance. So actually in mathematical modeling, the conditions on solutions are very important. You know that everything can start from time t equal to 0. So initial conditions are important in mathematical modeling. At time t equal to 0, what is the value of that quantity at instant at time t equal to 0 is important. So initial condition and boundary conditions on solutions with differential model is important here. So what is actually initial condition? You know that in mathematics, differential calculus and differential equation theory. So initial condition, you know that it is condition given at only a single point. If solution is defined on some domain, it is interval or some disk, then what is the condition on solution? It is given at single point x0. Suppose x0 belongs to interval I, and what is the value of that solution at that point initially is given there. And so differential equation with that initial condition is known as initial value problem. So in application point of view, the initial value problem and boundary value problems are very important. So here L of y equal to 0, we define initial condition phi of x0 equal to alpha, phi dash of x0 equal to beta. It is given with this differential equation, and these two things commonly known as initial value problem. Also boundary value problem. Boundary value means boundary condition means condition given at two or more different points of that domain, solution value of solution at that two or more points, and with the differential equation with boundary condition at 2 points, x0, x1, or more points also, x2, x3. So these conditions given with solution with differential equation known as boundary value problem. So here is one of the example. L of y equal to 0 is homogeneous equation, homogeneous linear boundary value problem, also homogeneous non-linear boundary value problem are there. Depend on the nature of differential equation. It is homogeneous, non-homogeneous, linear, non-linear, ordinary or partial. So these problems occurs in all types of differential models. But here we find a here solution. But it is important to know to us that the every initial value problem has solution or not. Guarantee of solution is there. So that guarantee gives by using existence theorem. You know that in here existence theorem, there exists a solution for every initial value problem. These are the basic theorems of differential equation theory, and also uniqueness theorem. How many solutions for initial value problem or boundary value problem? There exists at most one solution for every initial value problem, and exactly one solution, because existence theorem gives the guarantee of solution and uniqueness theorem says that there is at most one solution. And so in combination, existence and uniqueness says that every initial value problem exists a unique solution. By using that initial condition, we find the values of arbitrary constants C1 and C2 that are the parameters of here general solution contains constants, and by using condition we find constant and we get the particular solution, and therefore there is a unique solution. Proofs are also given in the ordinary differential equation, theory of ordinary differential equation by Coddington and Livingston. Very nice book. And in that book, the proofs of existence and uniqueness theorems are given there. So existence of the solution is important in the theory of differential equation. And also there are different traditional and standard methods given in the degree course for classical solving classical differential equations. We know that for first order equations, there are different methods by using integrating factor, variable, separable, converting into exact differential equations. And also the nth order equation, you know that we find a general solution of nth order differential equation, which is if non-homogeneous, then there are two parts of solutions. One is complementary function and other is particular integral. And we know that how to find complementary function by using short methods and also by using auxiliary equations. Find the roots of auxiliary equations, and depend on that roots, algebraic methods are theirs. And also some different methods are given in the literature. Also some standard methods to find solution of partial differential equations. You know that Charpit's methods, Jacobi method is given. Laplace transform method is also, you know that Laplace transform is a integral transform, Fourier transform, Laplace transform. So using different integral transform, there are different methods developed by the mathematicians to solve the differential equations. Also there is a power series method, and in that power series method actually is important in the case of to test the convergence and divergence of the solution of the differential equation. Adam in decomposition method, also recent methods, improved Adam in decomposition methods to find solution of differential equations. It is a classical differential equation or fractional differential equations also solved by using these methods. And there are different iterative methods also, finite difference method, numerical methods, because in some models, actually some differential equations are not solved by using standard or traditional methods, or so we use iterative methods and numerical methods for solving such complicated models which are non-linear or linear. Also recently there are in information technology, there are different softwares which are used to find the numerical solutions of differential equations, that are, you know that Python language, Scilab software, Mathematica software are there available online, or some softwares are free of cost. Also there is a software LaTeX for mathematical typing. So in the new national education policy, we need to know about the such type of softwares. It helps to solve the differential equations and also different mathematical skills. So next point is applications. You know that there are different applications of differential equations. Students are not aware about the applications of differential equations. Here, differential equations have a remarkable ability to predict the world around us, because different changes in the nature are expressed in the form of differential models. There is a wide variety of disciplines from biology, economics, physics, chemistry, engineering, technology. Some applications of differential equations in real life are as stated here. In population model, you know that in biology there are population model species, population model of different species, different diseases, and species models of different diseases in biology are also doing by using differential derivatives and differential. Yeah. Newton's law of cooling, you know that, radioactive decay law, molecular biology. In computer science, you know that also in game developing, differential equations are used. In electric circuit, modeling of electric circuit, differential equations are used. So one of the application is a population model. You know that exponential growth of population. What is meant by exponential growth? This population increases very rapidly. One of the basic example of differential equation is the Malthusian law of population growth. It is dp upon dt equal to r into p. Here p is the population changes with respect to time, and r is the change depending on the species. Species. It is not only the population of people, population model of species, different species. Model of Newton's law of cooling is, you know that, in previous slides. So next is exponential decay and radioactive material. So here is the differential model of decay and growth, radioactive material. M is the amount of product that decreases with time, and rate of decrease is proportional to the amount M. So that rate is expressed in this form, dm upon dt equal to minus k into m. Here and solution of this model is m equal to, by variable separable method, taking m in LHS and taking dt in RHS. So dm upon m equal to minus k into dt, and integrating, and we get the solution m equal to capital A into e raised to minus k. In molecular biology, mathematical cell biology is a very active and fast growing interdisciplinary area in which mathematical concept, techniques, and models are applied to variety of problems in development, mental medicine, and bioengineering. So models of various diseases are also expressed in differential form. And so in molecular biology, use of differential equation is there. So recently in computer science, mathematical logic, machine learning, and financial analysis, with this game development theory. So am I audible?
Yes, sir. Yes, it is now audible.
Okay. How much time, sir? Hello?
Sir? Sir?
हा, किती वेळ घेऊ शकतो सर?
घ्या सर, तुमच्या सोयीनुसार सर. टॉपिक कव्हर करा.
Okay. Okay. So there are other applications of differential equations.
Sir, your voice is not coming. Please unmute yourself.
Okay.
And
Okay. Is it clear, sir?
sir, your voice is not coming
Sharing screen
properly.
once again.
Okay.
Okay. Range problem. Here. Am I audible, sir?
Yes, sir.
Okay. I'm sharing screen here once again. Is screen visible, sir?
Yes, sir. Yes, that is visible.
Okay. So, some differential equations recently in a modern period, differential equations are applicable in different branches of science and also in engineering. So modeling of chemical reactions also using by differential equations, modeling of biological model, this modeling of diseases also here, modeling of cancer growth and spread of disease. Also, you know that in corona period, the mathematical model of corona is done by using differential equation, and there is fractional calculus is used here in to form the mathematical model of coronavirus in corona period. So that model, such type of models are also done by using differential equations. Also motion of waves, KdV equations, Cartwright de equations also obtained by that models are also using derivatives. So there are different models of waves also. Recently, there are different softwares to find the solutions of differential equations. You know that. So mathematical software is very important also. MATLAB software is used to find the numerical solutions of differential equations. In this way, so differential equation is very important branch of mathematics. In modeling and other things, there are different applications of differential equations. Can I stop, sir, here?
Okay, sir. Okay. Thank you, sir.
So, thanks to all for giving attention here. So, now I request you, if there is any question, then ask me. Is any question?
If you have any query regarding the session, please feel free to ask. Our experts address your queries.
Hello, is I'm audible?
Yes, sir. Yes.
Good afternoon, sir. Prashant here. So
Yes,
it was very nice lecture, nice, enlightening and informative lecture. But I would like to ask one question about OD and PD. OD and
yes,
PD plays a very important role to understand the weather and atmospheric science, isn't it? But the
yes.
mathematical model doesn't holds good to understand the weather and climate. Okay. So what is your view on that, and what calculation we can have or we can consider to solve to get the accurate forecast using the mathematical model or using OD and PD? So what is your bird eye view on that, and we would like to know your uh, thoughts on that. Thank you, sir.
Yes, sir. Your question is very nice, very good. Mathematical model actually derivatives is the rate of change, and every rate of change of the nature is done by using derivatives. And also there is a model for every change. We form the model of every change in the nature. And recently there are different softwares to find the approximate solutions for any type of model by using different methods, iterative methods, Laplace transform methods. Also, for that sudden changes, The recent branch of mathematics is the fractional calculus, and fractional derivatives are used to define such type of models. And by using that fractional differential models, we express every change in the nature. And that models, there are different methods to find the solution, approximate, not exact, but approximate solutions and numerical solutions. So there are different softwares to find the solutions. So that is the recent mathematics. Researchers also study this recent calculus, fractional calculus, from last 3 centuries. It is the most captivating branch in the mathematics, and many researchers doing research on this field. So every model has a solution using different methods. Are you got answer, sir?
Yes, sir. Yes, sir. I got your answer. Thank you. Thank you so much, sir.
Thank you.
But still, sir, I do have one doubt. If we have a same initial condition in the real atmosphere and we run a ordinary differential equation or partial differential equation on that real boundary condition, so at the end, if we look at the output, it doesn't same. So whether it is a real atmospheric condition boundary problem or whether it is a problem of the solution which is coming from the OD and PD.
Yes, but by using initial condition, we find the particular solution.
Oh, okay. So that should not suppose to the or that is not a mistake by calculation, or that there is no mistake in the equation itself, isn't it?
No.
Yes, got it, sir. Thank you so much.
Okay. Any other participant?
Any other query? Okay, thank you, sir. Thank you very much for your enlightening and motivating session on this differential equation and its application. Sir has started from basics of differential equation and cover all subtopics within very short period of time. Thank you, sir. We are grateful for your valuable insights. Thank you once again. Now there is one instruction for all the participants. I am sharing the feedback link within the chat box. Please submit your valuable feedback to us through the link. I am sharing this link in chat box session. Now, I would like to request Dr. Vijay Kumar Kumbare sir to vote of thanks for this event. Over to Dr. Vijay Kumar Kumbare sir.
Good afternoon to all. I am Dr. Vijay Kumbare, Faculty of Commerce. I am here to express vote of thanks of all participants and guests and students. Firstly, I express my sincere gratitude on this occasion to our respected principal for charging the sessions and conveyed the presidential talk on the occasion of one-day state level online workshop on differential equation and its application. Thank you, sir. And another, express my sincere gratitude to the today's workshop resource person, Dr. Shankar Raut sir, HOD, Department of Mathematics, KSK College Bid, for enlightening the differential equation and its application on this occasion. Thank you very much, sir. I also express my sincere gratitude on the occasion of this workshop, HOD of Mathematics Departments, Senior Professor Dr. M.A. Jogde sir, Vice Principal of the college. Next, my sincere gratitude to the Dr. M.N. Gaikwad sir, Vice Principal of the college. And at last, I express my gratitude to all the participants and entire faculty of mathematics and science and students who are patientfully and actively listening the sessions. With the permission of the chairperson, I declare this online workshop is over. Thank you very much. Thanks to all.
Thank you, sir, for giving this opportunity.
Welcome, sir. Welcome.
Gade sir, thank you.
Sir. Thank you, sir. Thank you.
लिव्ह करू का सर मीटिंग?
हो सर, हो. मी सेंड करतोय मीटिंग. फक्त फीडबॅक लिंक जी आहे ती शेअर करतो अजून. Once again, I would like to request all the participants, please submit your feedbacks. These feedbacks are valuable for us